Good morning, pre-calc. It's Coach Jackson, and today we're in the second section of Unit 4, the first unit of trig, and we're going to talk about probably one of the most useful um, pieces of information you can use as a student when learning trigonometry, and that is the unit circle. You should have been exposed to this in Math 3 a little bit. I'm going to go from the very beginning, show you how to label the unit circle and how they come up with all the radians and degrees and points that are on the unit circle. Remember, the unit circle is basically a circle that is overlaying a coordinate plane. So it's got an X and Y axis. Okay. The first thing we're going to do is we're going to label this circle in degrees. Okay. So at this point over here on the x-axis, this being the center of the circle, we are at 0 degrees. Okay. And it goes in a pattern. You add 30, 15, 15, 30. So if I add 30, I'm here. If I add 15, I'm here. If I add another 15, I'm here. And if I add another 30, I'm at 90. Okay. 30, 15, 15, 30. And I keep repeating that. Add another 30, 15, 15, 30. Halfway around is 180. Okay. Add another 30, 15, 15, 30. Put my little degree sign. Add another 30, 15, 15, 30. So there's our unit circle labeled with degrees. You should know how to do that. Now what we're going to do is we're going to convert all those degrees to radians. And we've already talked about that in yesterday's lesson. We need to multiply each one of these by pi over 180. And we're going to write our degrees as a radian, or as a radian form. So 30 degrees times pi divided by 180. 30 divided by 180 reduces to 1 over 6. So this is pi over 6. 45 times pi over 180. 45 over 180 reduces to pi over 4. It's 1/4. 60 is 1/3 of 180. 90 is 1/2 of 180. Okay. What's 120? 120 divided by 180. Some of you may have to pick up a calculator and do that. 120 divided by 180. 120, get rid of those. 120 divided by 180. Math, enter. We get 2/3. So this would be 2/3 or 2 pi over 3. 135 divided by 180. Math, enter, is 3/4. So this will be 3 pi over 4. 150 divided by 180. Math, enter. 5/6. So it'll be 5 pi over 6. 180 divided by 180 is 1, so this will be pi. Let's go ahead and do 210 divided by 180. Math, enter. We get 7/6. So this will be 7 pi over 6. 225. Get 5 over 4. So that's 5 pi over 4. 240. 240 divided by 180. Math, enter. Is 4 pi over 3. And then we got 270, that's down here, that's 1.5 pi, so that's 3 pi over 2. 300 divided by 360 is 5 pi over 6. 315, we did a couple of times when we were doing the conversion from radian to degree and degree to radian. We came out with 7 pi over 4. And then 330, I believe, was 11 pi over 6. We've done those calculations. And then 360 is at 2 pi. So if you know how to convert and you know how to label your unit circle in degrees, you should be able to get the radians. Okay. Now, since the unit circle is on a coordinate plane, each one of these points has a coordinate x and y value. And what I tell my students is if you can remember the ones that are in quadrant 1, they just repeat. Okay. So here, I'm going to show you how we calculate one of them, and then I'm going to label the rest of them in there. So if we were to draw this angle, okay, if we were to draw that angle, we know it's 30 degrees. And if that's 30 degrees and this is a right angle, the radius of a unit circle is 1. Always 1. And if you remember from Math 2, I believe it is, if you have a 30, 60, 90 triangle, your short leg is x, your long leg is x squared root of 3, and your hypotenuse is 2x. Okay. So if I know my hypotenuse is 1, I can figure out that x equals 1/2. Well, what's my x distance? My x distance is this. So that should be 1/2. Okay. I'm sorry. This should go up here. That's 1/2. That's the x distance. The y distance is going to be x times square root of 3. 1/2 times square root of 3 is square root of 3 over 2. So that's how we get our distances. Okay. So I'm going to make some room here. So my x coordinate and my y coordinate start at 30 degrees, and one of them is going to be 1/2, one of them is going to be square root of 3/2. Okay. When I do 45, (45, 90), my two legs are x, my hypotenuse is 1. So that means my x and y value are going to be the same thing. Okay. The leg of a 45, 90 is x, and the hypotenuse is x square roots of 2. Well, if I take x square roots of 2 and set it equal to 1, I can solve for the legs. I need to divide by square root of 2. I get x equals 1 over square root of 2. I can't leave a denominator as a radical, so I multiply by the conjugate. And I get x equals square root of 2 over 2. So all of these coordinates around the unit circle are going to be values of 0, 1, -1, 1/2, square root of 3/2, and square root of 2/2. Those are the only values that are going to be in our unit circle coordinates. We just need to know what they are and where they go. Okay? So my first point, let me get rid of some of this on here. So that's how they come up with them. Now we're going to write them in. This one, square root of 3/2 and 1/2. Here, square root of 2/2, square root of 2/2. Here, this one's going to be 1/2 square root of 3/2. This point right here is x value is 1, y value is 0. Up here at 90 degrees, we go 0 left and right, so 0 for the x, 1 for the y. Okay. This one over here at 180 degrees is -1, 0. Down here at the bottom is 0, -1. Okay. Now, if you know this much, we can just use these same ones and move them over. And they move in a rectangular form. Just remember that in quadrant 1, everything is positive, x's and y's. Quadrant 2, the x is negative, the y is positive. Okay. Quadrant 3, both are negative. And quadrant 4, the x is positive and the y is negative. So let me show you how this works. If I want this 30-degree angle, it's going to come straight over here. Okay? So over here at this point, I'm going to have square root of 3/2 and 1/2, but the x is going to be negative. Okay? This one is going to come straight over here. It's going to be square root of 2/2, and the x and the y, but the x is going to be negative. This one moves over here. It's going to be -1/2 and square root of 3/2. This one moves straight down here. Both are negative in this one, so I'm going to have negative root 3 over 2 and negative 1/2. This one comes down here. Both are negative. This one's going to be the negative 1/2 and negative root 3 over 2. Then we move them over. Okay? Then come over here and we rewrite them. But the y value is going to be negative in this one. So here we'll have 1/2 and negative root 3 over 2. Here we'll have root 2 over 2 and negative root 2 over 2. Here we'll have root 3 over 2 and negative 1 over 2. And then we're back up at 2 pi. Okay. So this is your unit circle. You need to be able to reproduce this. It will help you greatly with problems. So if you haven't drawn it out yet, please do that. Okay. Now, one important piece of information that you need to know with the unit circle and these x and y coordinates. These x and y coordinates, the x coordinate is the cosine, the y coordinate is the sine. Okay. So, the cosine of 30 degrees is square root of 3 over 2. The sine of 30 degrees is 1/2. Also, cosine of pi over 6 is square root of 3 over 2. Sine of pi over 6 is 1/2. That's how it works. We're going to work some problems with it. Okay. But you need to be able to reproduce the unit circle, have a mental picture in your mind in order to solve these trig problems. This is one of the most important pieces of the trig. So here's the definitions of trigonometric functions. Again, your sine of an angle is the y value. Your cosine of the angle is the x value. You can get tangent by dividing sine by cosine, y divided by x. Cosecant is the reciprocal of sine. So we flip it and we get 1 over y. Secant is the reciprocal of cosine. So if we flip it, we get 1 over x. And cotangent is the reciprocal of tangent. If we flip it, if you flip y over x, you get x over y. Okay. So here's what we're going to do. We're going to take one angle off the unit circle and we're going to reproduce these 6 trig functions. We're going to use pi over 6. Okay. So at pi over 6, what is my x and y coordinate? Well, if you look back at your unit circle, pi over 6 is square root of 3 over 2 and 1/2. Square root of 3 over 2 and 1/2. And remember that cosine is the x, sine is the y. So sine of pi over 6, or the y value, is 1/2. Cosine of pi over 6, or the x value, is square root of 3 over 2. Tangent, we have to take y divided by x. So if I do y divided by x, I've got a complex fraction. And in this, if your denominators are the same, they cancel each other out. Okay? So I really have 1 over root 3. But I can't leave root 3 in the denominator, so I have to multiply by the conjugate, which is the square root of 3 over the square root of 3. 1 times square root of 3 is square root of 3. Square root of 3 times square root of 3 is the square root of 9, which is 3. So my tangent for pi over 6 is square root of 3 over 3. Now remember, cosecant, secant, and cotangent are all reciprocals of sine, cosine, and tangent. So all I need to do, if I've got sine, cosine, and tangent, I just need to flip those to get the answers for the other 3. So what happens if I flip 1 over 2? Well, I get 2 over 1. What happens if I flip 3, square root of 3 over 2? I get 2 over square root of 3. But I can't leave it like that. I have to multiply by the conjugate to get 2 root 3 over 3. And tangent of pi over 6, if I flip square root of 3 over 3, I'll get 3 over root 3. And I can't leave it like that. So I get 3 root 3 over 3, and the 3's cancel, and I get root 3. So I could have flipped this one and gotten cotangent. So that's how you use the unit circle to find all 6 trig functions. And we'll get some more practice with that today. All right. Now we want to do it for the angle negative pi over 3. Now remember, negative angles go in a different direction. Okay? Negative angles go in a different direction. Let's go back to our unit circle. If I want to go negative, I have to go clockwise, and I go a distance of pi over 3. Well, the distance of pi over 3 is 60 degrees. I just need to go 60 degrees in a negative direction. That would put me here at 300 degrees, which is 1/2 and negative root 3 over 2. 1/2 and negative root 3 over 2. So there's my cosine, there's my sine. All right. Let's fill them in. The sine is negative root 3 over 2. The cosine is 1/2. Tangent is the y divided by the x, or sine divided by cosine. So I'll have negative root 3 over 2 divided by 1 over 2. The 2's cancel. I've got negative root 3. Okay. All right. Now all I got to do to get cosecant, secant, and cotangent is to flip all the others. So if I flip this one, I'll get negative 2 over root 3. Multiply by the conjugate. So I got negative 2 root 3 over 3. This one, if I flip 1/2, I get 2. And this one, if I flip negative root 3, I'll have negative 1 over root 3. And then I got to multiply by the conjugate. And I get negative root 3 over 3. So it helps if you know the unit circle. Okay. Let's talk about domain and range. Domain of sine and cosine function is the set of all real numbers. Just to give you a heads up, the sine function looks like this. It goes toward the negative infinity and positive infinity in both directions. Cosine looks very similar, except it starts up there. It goes in both directions toward negative infinity and positive infinity. Okay. The range of sine and cosine, it goes from -1 to 1. And these are periodic functions. That means that it starts repeating itself after one cycle. Okay. So using the period to evaluate sine and cosine can be done. Okay. So if I have an angle of 13 pi over 6, I know that goes around the unit circle more than once. Okay. So I can take out one full revolution, and I know that I've got pi over 6 left. Okay. And here's what it would look like on the unit circle. If that's my unit circle, and I want 13 pi over 6, I go around one full time, and then another 1/6, which puts me over here. And that's at pi over 6. Excuse me, pi over 6. I'm thinking pi over 3. Hang on. Start over here. Pi over 6 is at 30 degrees. And at that point, my x and y coordinate on the unit circle is that. So instead of trying to figure out sine of 13 pi over 6, I can just use sine of pi over 6 because I know it's at the same point. Okay? It's a reference angle. It's a coterminal angle. Okay? So sine of pi over 6 would be 1/2 for that one. Remember in unit 1, we stated that function is even if you plug in a negative x value and you get the same thing that you started with. It's odd if you plug in a negative angle and you get the negative of what you started with. Well, there are only 2 even functions in these 6 trig functions, and that's cosine and secant. They're the only ones that are even. All the other ones are odd. Okay? All the other ones are odd. So cosine and secant are even. Sine, cosecant, tangent, and cotangent are all odd functions. That's it for today. Concentrate on memorizing or being able to draw the unit circle. That's very important. I'll stay online here and help you on the Zoom if you need some. Have a good day.